solve the following radical equations, be sure to justify your solution set, which means check for extraneous solutions. Make sure you check that you don't get any extraneous solutions, because squaring things gets kind of sketchy. Squaring things is not really the best thing to do when solving equations because you can accidentally throw in some extra solutions. So, number one, to solve this square root equation, I need to get the square root all by itself, so that x has to move to the other side. So I'm going to add x to both sides. The square root of 2x minus 7 equals x minus 3. Now that I've isolated the square root, I can square both sides. I square both sides because squaring and square rooting are kind of inverses of each other. So I'm left with 2x minus 7 equals x minus 3 squared. Please do not do the 9th grade thing, multiply it by itself. If you need to make a table, great. If you want to use the identity, great. Somehow you need to end up with x squared minus 6x plus 9. You should be comfortable at this point with multiplying binomials. It's a quadratic equation, so I need to set it equal to 0. So I'm going to move these terms over and set it equal to 0. 0 equals x squared minus 8x plus 16, and now that it's set equal to 0, I need to factor. I need to ask myself, it's a trinomial, what two numbers multiply to 16 that add to negative 8? Well, that's negative 4 and negative 4. So it looks like I have a repeated root here of x equals 4. So x equals 4 could be the solution, but I need to check it. I need to check. Otherwise, it could be extraneous and there could be no solutions. So I get the square root of 2 times 4 minus 7 minus 4. Does that equal negative 3? Well, the square root of 8 minus 7 is the square root of 1 minus 4 equals negative 3. 1 minus 4 does equal negative 3, so this does check out. So x equals 4 is the solution, is the only solution to this radical equation. Number 2, the square root of negative 10 plus 7x equals x. Well, the radical is already isolated, so I just need to square both sides. Squaring both sides, squaring isolates the radical, so I'm left with negative 10x plus 7x, negative 10 plus 7x equals x squared. It's a quadratic equation, so I'm going to set it equal to 0. I like having a positive x squared term, so I'm going to move these terms over and write it in standard form. X squared minus 7x plus 10, just so it's in standard form. Now that it's set equal to 0, I factor. It's a trinomial with a leading coefficient of 1, which is nice. So what multiplies to 10 that adds to negative 7? Well, negative 5 and negative 2. So we get x equals 5 and x equals 2. But I need to make sure that these are actually solutions and just didn't appear from me squaring both sides. How do I do that? I plug them in. So first let's check x equals 5. The square root of negative 10 plus 7 times 5, does that equal 5? Get the square root of negative 10 plus 35, does that equal 5? I hope it does. The square root of 25, does that equal 5? Yes, it checks out. So x equals 5 is a solution. Now we get to check x equals 2. The square root of negative 10 plus 7 times 2 equals 2. So 2 is a solution to this quadratic. It's a solution to these equations, but is it actually a solution to the original equation? It's a very large square root there. The square root of negative 10 plus 8 equals, not 8 equals 4, plus 14. Negative 10 plus 14 is the square root of 4. Does the square root of 4 equal 2? It does. So x equals 2 also checks out. There's no extraneous solutions here. They are both in the solution set. Number 3, the square root of 56 minus x equals x. Again, it's the same thing. Same structure as this one here. So I'm going to square both sides because the radical is already isolated. Squaring and square rooting are kind of inverses, so we get 56 minus x equals x squared. Move those terms over. Minus 56 plus x, minus 56 plus x. And I'm going to write that in standard form. And I get 0 equals x, how does this factor? multiplies to negative 56, that adds to 1 is 8 and negative 7. So I get x equals negative 8 and x equals 7. So I need to see if these are extraneous solutions or not. So let's plug it in. Let's plug these values in. The square root of 56 minus negative 8, does that equal negative 8? The square root of 64, does that equal negative 8? Hopefully this is a warning light, because 8 does not equal negative 8. This is not a solution. X equals negative 8 is extraneous, so we throw it out. We don't include it in the solution set. What about x equals 7? 56 minus 7 equals 7. Hopefully this is true. The square root of 56 minus 7 is the square root of 49. The square root of 49 is 7, so only x equals 7 is in the solution set. X equals negative 8 is extraneous. It got thrown in there after I squared it. It's not really a solution to the original equation, but it is a solution to these other ones. Number 4. Number 4 is one of those harder types of questions, because I can't isolate the radical. I can't just make the square root disappear, because there's more than one radical. I can't just get them on one side and isolate it. So unfortunately, we just have to square both sides. We just have to square both sides. And I get x plus 4 equals 3 plus radical x times 3 plus radical x, because we're not in 9th grade and know how to square binomials by this point. How do I multiply two binomials together? I use the distributive property or a box. You get 3 times 3 is 9, 3 times radical x is plus 3 radical x, radical x times 3 is plus 3 radical x, and the square root of x times the square root of x is just x. So I have x plus 4 equals 9 plus 6 radical x plus x. Well, the first thing I'm going to do is I'm going to subtract that x over, because now I have only one square root to deal with and can isolate that radical. Going to now isolate this radical, so subtract 9. Negative 5 equals 6 radical x. And divide by 6. And get negative 5, 6 equals radical x. And this is one of those moments where you want to stop and look at the equation and say, wait a minute, the square root of what number gives me negative 5, 6? There is no real number x that does that. So we say there's no solution right here. I know I can stop and say there's no solution because there's the square root of what number, the square root of what gives me negative 5 over 6. It can't happen because your output can't be negative when I input into the square root function. So you could keep solving, check your answers, it's going to be extraneous. Don't go through all that time, because if you stop and actually look at the equation and say, wait a second, that can't be, that's extraneous. So there actually are no solutions to this equation. You could check this graphically and see that those two functions will never intersect. Number 5, prove that x equals the square root of negative 5x minus 6 has no solution. Now, you saw the word prove and started panicking for no reason. Just solve the equation. Solve the equation and show that it has no solutions. The radical is already isolated, so I'm going to square both sides. X squared equals negative 5x minus 6. This is a quadratic equation, so it should be set equal to 0. It's always 5 and 6 when factoring. Hopefully by now you've figured out how to factor these and actually stop and think for a second. What multiplies to 6 that adds to 5? Plus 3 and plus 2. So once I apply the zero product property, I get x equals negative 3 and get x equals negative 2. Are these actually solutions? I hope there's not, so I'm going to plug them in. Does negative 3 equal the square root of negative 5 times negative 3 minus 6? Does negative 3 equal the square root of 15 minus 6? Does negative 3 equal the square root of 9? No. The square root of 9 is 3, so this is extraneous. We reject it. That's an extraneous solution. Let's check x equals negative 2. Does negative 2 equal the square root of negative 5x minus 6? Well, x is negative. We know that x is negative 2, so let's substitute that in. So we get negative 2 equals the square root of 10 minus 6. Does negative 2 equal the square root of 4? That's not a true statement, so we also reject this one and call it extraneous. It's a solution to our transformed equation, but it's not actually a solution to the original equation. So, we have shown that there are no solutions. We have proved there are no solutions to this equation. Don't panic because it says the word proof. You can only do that in geometry. Number 6, what about a rational equation that has a radical in it? Solve the equation below for x. So, big picture here, this is a rational equation because it's a fraction. It's kind of rational. It looks like a rational equation. So, to solve a rational equation, I get a common denominator. Well, what's our common denominator here? The square root of x minus 2. So this is 5 over the square root of x minus 2 equals 5 over 1. So that needs the square root of x minus 2 on the top and bottom. Nice review here of now that I have a common denominator, I only care about the numerators. 5 equals 5 radical x minus 2. Not minus 2. The distributive property, minus 10. Don't forget the distributive property. I did that on purpose. No, I didn't. Now we get to solve this radical equation. The radical equation, well, I need to isolate the radical. Add 10 to both sides. 15 equals 5 radical x. I don't care about 5 radical x, so I'm going to undo that multiplication by division and get x equals the square root of 3. Not x, I get 3 equals the square root of x. Don't listen to me. 3 equals the square root of x. How do I get x by itself? Square both sides, and we get x equals 9. X equals 9 is apparently the solution to this radical equation. So, let's check to see if it actually is true. Is 5 divided by the square root of 9 minus 2 actually equal to 5? Well, 5 over 3 minus 2 is equal to 5 over 1, which is 5. So it does check out. X equals 9 is the solution. Now this is where that seeing structure thing comes into play. After I picked this problem to put on your homework, I said, wait a minute. 5 over what gives me 5? 5 over what has to give me 5? Well, 5 divided by 1, that number down there has to be 1. So the square root of x minus 2 has to equal 1, because 5 divided by 1 is the only way to get 5. So if we see this, if you saw that structure there, which I'm assuming no one did, and that's okay, because do you really need to know how to do that? No, seeing structure is something you have to learn over time, and you get x equals 9 still. So it saves us some of the mess. But recognizing 5 over 1 equals 5, well, that denominator down there has to be 1. That's lesson 10, solving rational equations, radical equations again. This is an important lesson. It's going to pop up on your Regents exam in June somehow. Make sure you're able to solve a radical equation when they're more complicated, and you can't just use inverse operations. You have to go through and check. You have to go through, you probably have to do x minus 3 squared. You probably have to go through that process and then check your solutions at the end. Don't forget that we can solve these graphically, though. Solving equations graphically is such a powerful tool. Throw one side in y1, the other side in y2. It's a quick way to check your solutions as well.